Hello! In this video, I'm going to show you how I implemented Milestone 4. If you don't know what I'm talking about, check the description and click the link to the full playlist. So what we wanted to do in Milestone 4 was get the BombCounter to work and get the Stopwatch to work and detect the end of the game. So the BombCounter starts off as displaying how many bombs there are hidden in this board. And when you flag cells, the counter goes down. So basically this counter is the number of bombs in the board minus how many flagged cells there are. And if it gets to a negative number, it displays a negative number. And it doesn't matter whether the flagged cells are correctly or incorrectly flagged. Additionally, this stopwatch starts the moment you expose the first cell, okay? So if you expose the bomb as the first cell, then you've immediately lost. But if you expose a cell and you're still playing, then this starts off as 1 and starts to go up from there. And let me show you, let me win the game. So all the cells become flagged once you win the game. The smiley becomes smiling with the sunglasses, and the stopwatch stops, and then you can reset the game here. So let me show you how I implemented that. This was the trickiest part. The stopwatch was the trickiest part to start it and stop it accordingly. All right, so remember the BoardTopbar component? It's the component that contains this, that renders this. It renders the BombCounter, the smiley button, and the stopwatch. And also this nice bevel all the way around it. So this is the bevel, and then you have the BombCounter, the smiley button, and the stopwatch. So let's start with the BombCounter. BombCounter, very, very simple component. It returns a counter, which is just a component that believes whatever value you give it and displays that value. Okay, let's do like a -6. Just displays whatever value you give it, renders that. So here, the BombCounter obviously has a changing state with the correct value to be displayed. And the way that this value is updated is with a use effect, that every time the game changes, it sets the value to be whatever the game service tells it should be. So the game service gives this service of, give me the BombCounter value, and that's it. This component doesn't have to do anything. This component doesn't have to detect that a cell was flagged, a cell was unflagged, the game was won, the game was lost. It doesn't have to detect any of that, but it only has to ask the game, check when the game changes, and ask the game service to recalculate what the BombCounter value should be. And this makes the component much simpler. This makes the model much more complete. And this prevents bugs of edge cases of, hey, wait, did I update the BombCounter when the game ended? Did I do this? Did I do that? Okay, so how does the game service supply the BombCounter value? Let's take a look. So the BombCounter value is just the difference between how many bombs there are in the game minus how many flagged cells there are in the cell states. So what is bombs count? We didn't have that before, did we? So let's take a look. When we reset the game, we have the solution, right? And this solution contains a certain number of bombs, and that's it. It's not going to change for the duration of the game. So when we reset the game, I want to count how many bombs there are in the solution matrix. And that's it. That's the bombs count. I'm not going to recount that over and over and over again. I'm only going to count it once when I reset the game. Okay? And then how do I count the bombs? Very simple. You get a matrix, and then I implemented this helper function, count cells, that counts how many cells in this matrix contain this value. So how many cells in the solution contain BB, which is how a bomb is represented in the model. And the way that this function works is with a double reduce. So reduce the matrix and then reduce each row in the matrix. And for each cell in the row, if the value of the cell is equal to the requested value, add 1 to the accumulator. Otherwise, don't add anything to the accumulator. So basically what this does is return how many cells in this row have this value. And then this counts or tallies up, counts all of the, sums up all of the counts of each row in the matrix. So if you're not familiar with reduce, then please learn it. Please practice it until you feel familiar with it and it's easy for you to write reduce, okay? Because yes, you could implement this with a double for loop, but reduce is the more elegant way to do it because you are stating your intention. I intend to reduce this matrix to something smaller, to something more compact, you know? So it's better to do it with reduce, I think, in terms of good practice, you know? Okay, so that was count bombs. And then you also have count flags, right? So it also uses the count cells function. It says how many cells in the game's cell states are FL, right? So what is cell states? Remember what that is? Cell states is that overlay on top of the solution, which starts off as un, because all the cells are unexposed. And whenever you flag a cell, something becomes FL. So, like I said, the BombCounter component has no idea what causes flags to be added or removed from the cell states. It has no idea. And then what it does is to each time say, okay, has the game changed? Okay, can you please recalculate the BombCounter value for me, right? This is how a model should be written. The components should be very, very stupid. And when you write the model, you need to ask yourself, what if this was not an HTML page? What if this was like a terminal game, a game that was implemented in the terminal? Then my model will look exactly the same, okay? So this is something I think is very important because, you know, components get complicated very quickly. And you don't need that kind of complication. You want your code to be as simple as possible. Okay, enough of my rambling. So that is how this works. And then when the game is won, let me show you how the game is won. Let me do a little digression or hopping segue to something else. Remember I told you that when I expose cell, after I expose the cell, I want to check if the game is won. How do I check if the game is won? I check if solution.every, so in the solution of the game, is every row and every cell in the row either a bomb or an exposed cell. Okay, so basically what this does is return true if every cell is either exposed or a bomb, meaning all the non-bomb cells have been exposed. So again, if you're not familiar with every and some SOME, please learn them, please practice them on just simple vectors, simple arrays, and get to know them. So I check, after I expose a cell, I check if the game is won. And if it's won, I set the status to 1. And if the game is won, I flag all the bombs. Okay, because I told you when you win the game, all the bombs become automatically flagged. And how does that happen? It's a for each on the game solution. And for each cell that is a bomb, change its cell state to flagged. That's it, very simple. Okay? And as a result of winning the game, the BombCounter will automatically go down to 0. Why? Because get BombCounter value will subtract the bombs count, will subtract how many flags there actually are from the bombs count, and it'll be 0, okay? So you don't have to manually update it to 0 and everything. It all comes from the model. Very simple, very bug averse, okay? So I showed you how I detect the winning state. So let me just finish that up, okay? So if let's win the game. Let's win the game. And let's just do a few flags. And now I'm going to click on this, check that, see that all of these are about to be flagged, and this will go down to 0, and this will stop here. And he'll get sunglasses. Look, I'm going to uncover the cell. That's it. I won. All of these have been flagged. He gets sunglasses, and this went down to 0. So I explained that this went down to 0 because this component always counts how many flags there are and subtracts that from how many bombs there are. And the code that flagged these cells was what I just showed you. So I did an expose cell, right? Expose cell was happens when you do a mouse up on one of the cells. And then I checked, is the game won? And flagged all the bombs if so. So what did I have to do in order to, get this smiley to have sunglasses? Very, very simple. I just added another use case to my smiley button component, which in case the game status is 1, then the class name of this button is smiley sunglasses. So look, if I do inspect, you can see that the button's class is smiley button and smiley sunglasses. And then we just have a bit of CSS that says, okay, if the smiley button class also has smiley sunglasses class, then this is the background image, the smiley sunglasses, okay? Very simple, very straightforward. There is no, like I said, there's no manual changing of the smiley button to sunglasses, but rather the smiley button reflects or renders the model. So if the model says 1, the smiley button will say 1 WON. The smiley button will say sunglasses. Very, very simple, and this is how it should work. Okay? Components are very, very, very clean. And we have now reached the hardest part, which is this counter. Okay? So basically when you reset the game, the counter is at 0, and it immediately goes to 1 when you expose a cell. So let's see how the stopwatch, sorry, it's a stopwatch. Let me show you how the stopwatch is implemented. I will say that I implemented it at first using a custom hook called useInterval, and then I erased that because it wasn't good enough for what I needed, and I use useEffect. So we have this interval ID, which is a useRef, and this interval ID starts off as null. At some point, which I will show you, I use setInterval so that every second I want to do get stopwatch value. Every second I update the stopwatch value. Okay, and we'll get into this in a few moments. But I just want to say this useRef is either null or it's the interval that's currently running every second. Okay, so I have a start function and a stop function. A stop function clears the interval and sets the ref to null. And a start function starts the interval to run every second, and in each second, it asks the game service, what should the stopwatch value be? And that is what it displays in the counter, right? Okay. So we have a use state for the value, and we have the interval ID. Now, how do we handle this? How do we get this interval to start, to stop when it should? So this did take a bit of like trial and error, and I will show you in a moment. I will add debug prints to show you like what everything does. So, by the way, I added a use effect that when the component exits, it stops the interval. It's quite meaningless because this component's never going to exit. It's never going to be removed from the DOM, but whatever. I added that just for cleanliness' sake. So you can ignore this use effect. It doesn't actually help us in any way. So this use effect looks at the game and asks the game for every change in the game. It asks, is the game status initial? If it is, reset the stopwatch, set the value to 0. When does this happen? For example, here the game is not initial, it's idle. And if I click here, this resets the game and puts it back to initial state, and that is why this goes back to 0, and that is why it doesn't start counting up, because I stopped the interval. I cleared the interval, excuse me. I stopped the stopwatch. Okay, and then I return. That's it. Done with this case. So now we ask, is the game over? Meaning, did we win or did we lose? In such a case, stop, okay? But don't reset the counter, okay? So if I lost, let's say I lost, the counter, the stopwatch stops, but it doesn't reset to 0. It shows me how long I've been playing, whether I've won or whether I've lost, and that's what I want. That's why I only do stop and return. Otherwise, if the game status is idle and we don't have an interval ID, then we set the value immediately to 1 and we start the interval. Okay, so what does that mean? That basically detects the case where you switch from initial status. So here the game status is initial. And when I do a mouse up here, it changes from initial to idle. Okay, and then when I do this, it also changes to idle. But by this point, the interval is not null. And that is why this detects a switch from initial status to idle status. Why do we set the value to 1? Because I told you that in the original game, the moment that you do a mouse up, this starts as 1. So that is why I did that. And I did start. Okay, so all we have left to do is to look at how the game service tells me what the stopwatch value should be. And again, as you can see, I'm not incrementing the value. I'm just asking the game service, given that this is the model, what should the stopwatch value be? And what the game service does in order to answer that question is very simple. It looks at the start time of the game, which I'll show you when we set that. It looks at the start time of the game. And if the start time is null, it returns 0. The stopwatch value should be 0. Otherwise, it subtracts now, or it subtracts the start time from now, divides it by 1,000, because this is in milliseconds, and it ceilings that, like it rounds it up to the nearest whole number. Okay, so as you can see, there is no place in the model that tells you what the stopwatch value is, that records what the stopwatch value is, but rather in our model, we have the start time of the game. That's it. The start time is null if the game hasn't started yet, and the start time is a certain time if the game has started. So let me just show you when the start time is set. So basically, that's where it was. I missed it. In exposed cell, we say, if there is no start time, then set the start time, because we've just exposed the cell. If we expose the cell, that's it. The game should be running. So if it's already running, don't reset the start time, right? But if we haven't yet set the start time, set it here. And you know what that tells me? That tells me perhaps I did not need an initial status. I could have done idle status, check if the game status is idle, and the start time is null, instead of having an initial status and an idle status. Don't know if I'm going to change that. We'll see about that. But this is how I did it for now. And I think that wraps it up. What do you think? So I remind you that the stopwatch has no idea of whether someone clicked this button. It doesn't have a direct idea that someone clicked this button. It doesn't have a direct idea that someone clicked the cell. It doesn't have an idea that someone stepped on a bomb. But rather, only the game has that idea, and the component indirectly receives this information. The component always re-renders the information. The component doesn't know anything. It re-renders the information. It reflects what the game model is. And I think that's awesome. I think that's the correct way to write code. And you can see how clean the components are. And like I said, you don't have all these edge cases. You have to make your model perfect. Okay, there's one thing I wanted to show you though. I wanted to show you, I wanted to add a print here, console log interval, and then let's do this. Why do I want to show you this? Let's do console, and I'm going to reset. See how the interval isn't running? If I expose a cell, the interval starts running, right? See? And obviously the number that's printed is going to be displayed here. If I reset the game, it no longer runs. I don't want it to run each second and say 0, 0, 0, 0. That's just, I thought it was cleaner this way. So let's lose the game. I've lost the game. This stops, right? And let's win the game. I won the game. This stops. I reset the game. This stops, right? Nothing is running. I flag something, nothing happens. I go into danger mode, I go out, nothing happens. Only once I expose the first cell, this starts running. So I didn't want it to run and just say 0 all the time. I wanted it to run when the game is running and to stop when the game is, in initial state or in game over state. So that was Milestone 4. I think it was lots of fun. And also, I think the game is fully functional, except for the, few things here and there. So I think in the next milestone, we will randomize the board. That should be very easy to do. It's just something, whenever you reset the board, you have to randomize the bombs, blah, blah. And we'll start by hard coding how many bombs there are, and then in a later stage, we'll make that customizable to beginner, intermediate, and advanced. So remember, in the real game, let me open the real game, which I closed for some reason, Minesweeper X. In the real game, you can have beginner, which is 1, 2, 3, 4, 8 by 8 with 10 bombs. You can have intermediate, which is I don't know how many, with 40 bombs, and you can have expert, and then you can also have custom, which, you specify the height and width and how many mines there are. So I think in the next milestone, what we'll do is just the beginner mode, but the bombs are randomized in the board. And I will say that it has been so helpful to work with the hard-coded bombs because it's easy for me to remember where the bombs are and to check my code accordingly. So I hope you found this helpful. I know it was a bit long, but I hope you, benefited from what I said. And I would love to hear, how was it for you to code this milestone? Was it hard? Was it easy? Did you miss any edge cases? Do you think my code can be improved? Do you think your code can be improved? I would really love to hear that because otherwise I'm speaking into the void. So I'll talk to you in the next video in Milestone 5.